about perpendicular bisectors, it's going to use some of our distance formula stuff again. What a perpendicular bisector is when we have something like a segment. That was a really terrible thing. We're going to try that again. So if we have a segment, the perpendicular bisector goes through the midpoint at a right angle. Bisector means cutting in half. What's up? This is still 3.1. This is chapter 3 in unit 2, which doesn't really make a ton of sense, but it's unit 2, chapter 3, section 1. So what this is saying is if this is point A and this is point B, any point on our purple line here is the same distance from A and B. No matter which point I pick, I'll get a different color here. If I look at this one, they are equidistant if that is a perpendicular bisector. What's up? Cool. Where? Ah, awesome. Thank you. I'll put that there. Okay. So, what we're going to be doing is we're going to be looking to see if we can prove that some line is a perpendicular bisector given some information, which means we're going to be checking distances. So we're going to see, is C on the perpendicular bisector of A and B? So what we have is we have a point A and a point B, and we want to know if C is equidistant. So we're going to find the distance here and the distance here, the distance from A to C and the distance from B to C. So we're going to use that distance formula from yesterday. The distance from A to C, we're using that square root of, we find x1 we're going to just put the values in. So for A and C, we're going to take our 5 minus negative 4 squared plus negative 11 minus negative 3 squared. This is going to give us the distance from A to C. The distance formula, we wrote the distance formula yesterday. Distance between 2 points equals square root x1 minus x2 squared plus y1 minus y2 squared. For those of us that forgot, there's our formula. So we're going to simplify these pieces. Square root. 5 plus 4 gives us 9. Negative 11 plus 3 gives us negative 8. 9 squared gives us 81. 8 squared gives us 64. So the distance here is square root of what? 145. So the distance between A and C is the square root of 145. We're just comparing that to BC. So we don't need to simplify that and get it down into a decimal form. So we're just comparing. So let's see if BC gives us the same distance. So, boop. Then we're going to do the distance of BC. So we're going to have that distance equals 5 minus 6 squared plus negative 11 minus 1 squared. Okay. Simplify each of the pieces. Square root 5 minus 6 gives us negative 1 squared. Negative 11 minus 1 gives us negative 12 squared. What is negative 1 squared?
1.
What is 12 squared?
144.
144. So what is 1 plus 144? 145. Square root of 145 is the distance between B and C. So is C on the perpendicular bisector of AB? Yes. Because AC is equal to BC. They are congruent. So the way we prove it is we show that they are congruent. I'm going to do the same thing again. We're going to prove C is on the perpendicular bisector of segment AB. Same thing. We've got A, we've got B, and we're trying to prove that C is on the perpendicular bisector. So we need to find the distance of AC and the distance of BC. So our distance of AC, square root of the difference of 4 minus 1 squared plus the difference of 7 minus 1/2 squared. Sorry, I have those flip-flopped. 1/2 minus 7. So we're going to have fractions sometimes, and they're going to be gross, and that's okay. 4 minus 1,
3 squared.
3 squared. 1/2 minus 7, 6 1/2. How about we do that as an improper fraction?
3. Oh. 13 over 2.
There we go, 13. Sorry, I kept hearing 3. I was like, definitely not 3. 13 over 2 squared. If we do it as an improper fraction, it's a little easier to see it. Negative, yes. Negative 13 over 2. So 3 squared gives us 9 plus 13 squared. What's 13 squared? 169 over 2 squared. Nine plus 169 over 4. What's 9 in terms of fours? So then 36 plus 169.
199.
No. So 9 in terms of 4. It's going to be that 36 over 4. 169.
Oh, 200.
205. When in doubt, write it down. Stop trying to do stuff in your head. Write it down. We do stuff in our head, we lose pieces. Okay? So 205 over 4. We're comparing lengths. We don't need decimals. This is the square root of 205 over 4. Let's see if this one is. So then we're going to do the distance between B and C. Four plus 3 squared and 1/2 minus 2 squared. Finding the difference in those 2 points, or the distance between those 2 points. So our distance is the square root of 7 squared plus 1/2 minus 2.
Is it negative 3 over 2?
Yeah, negative 3 over 2 squared. So when we have the fractions, make them improper fractions because they're less gross. I know that they're still gross, and that's okay. They're just less gross. So we're going to have the square root of 49 plus 9 over 4. That was my next question. What is 49 times 4?
196.
196 fourths plus 9 fourths. So what is the distance between points B and C? 205 over 4. Square root of. So is C on the perpendicular bisector? Yes. Okay. How are we feeling? Because it's going to kick up a notch. I know, right? So we're given 2 points. A is 1,7 and B is negative 3,2. We are going to find a formula. What I mean by formula is an equation. Okay, why can't I write the word equation? An equation that expresses the fact that some arbitrary point is on the perpendicular bisector. This is fancy schmancy math talk for find the equation of the perpendicular bisector between these 2 points. So what we're going to do is we are going to find when some point P, the distance between A and P equals the distance of B and P. So the way we can find the equation of the perpendicular bisector is to use x and y as our points for P when I already have points for A and B. So we're going to write the formula for distance for both of these. So the square root of the distance from A to P x minus 1 squared plus y minus 7 squared. So I want to see where I find all those pieces. We want to know when that equals the square root of same thing for B and xy. X minus negative 3, so x plus 3 squared plus y minus 2 squared. Okay? You see all the pieces? This paragraph means build this obnoxious sentence. We want to know when the distance is the same. How can I get rid of those square roots? Square both sides. That's a square. So that gives us x minus 1 squared plus y minus 7 squared equals x plus 3 squared plus y minus 2 squared. What can I do next to simplify this dang on thing? Square everybody. Everybody. X minus 1 squared. It's going to give us x. Oh, yes.
Yeah, wait, can you I gotta write.
Yup. Gotta write it down. Gotta write it down. So square out all the pieces. Multiply them out. When we do that, we should get x squared minus 2x plus 1 plus y squared minus 14y plus 49 equals, keep going out, x squared plus 6x plus 9 plus y squared minus 4y plus 4. I did the y's in green and the x's in purple, just so we could see them. What can I do to make this less gross? Can't combine like terms. I don't have any, the numbers are like terms. Subtract what? Any of the squared guys. Oops, sorry. Let me make that not so big. All right. Let me get my x squareds together. And my y squareds. What's going to happen with them? They cancel out. And already it's significantly less gross. I have minus 2x plus 1 minus 14y plus 49. So total over here is plus 50. And on the other side, I've got my 6x minus 4y plus 13. By getting rid of our squareds and combining like terms, it is already significantly less gross. All right, now what can we do? Can we get x's and y's together? Yeah, what are we going to do? Add 2x, fine choice. What else are we going to do? Plus 14y. It's winding up looking kind of like standard form, so let's get our x's and y's on one side and our number on the other. So I'm going to leave my 50 over here for now. We get 8x plus 10y plus 13. That's a y. And we're really close to a linear equation. What do we need to do? Subtract 13. And that'll put us into linear standard form. So we get 37 equals 8x plus 10y. And that is the equation of the perpendicular bisector of AB. That's your answer. That was a lot. It was a lot, I know. No, we're not going to find actual values because we don't have an actual value to plug in. We were given variables to plug in. They said an arbitrary point P, meaning that is the equation for every point that is on the perpendicular bisector, meaning that's the equation for the perpendicular bisector. Okay. Ready? Show that they are vertices of a square. What are the properties of a square? Four sides that are the same length and is a parallelogram. So it's sides the same length, it's a quadrilateral. So it means the sides are parallel, which means they have the same slope. So we're going to check that the sides are the same distance and that the slopes are the same. That's how we can tell if they are parallel. Because unfortunately, graphing it to look gives us an approximation. That'll prove if it's not, but it won't prove that it is. Because what if they're just barely off? We don't know. So, when it says show, that means prove. Anytime it says show, it means prove. It means you have to do it properly. So we're going to need the distance from A to B. To equal the distance from B to C. To equal the distance from C to D. To equal the distance from D to A. We need all four sides to have the same distance. If any of them are not the same distance, we're not a square. Four times. So distance from A to B. So we're going to have 1 minus negative 4, which gives us 1 plus 4 squared. And 4 minus 2 squared. I'm going to go sideways this time just to save some space. So we have the square root of 5 squared plus 2 squared. 25 plus 4. Square root of 29 is the distance of AB. Whoop. So then we're going to find the distance of BC, which I'm going to do in a different color just so we can tell the lines apart. What's up?
Let's say, for example, on the second distance, it doesn't equal the first one, and we stop there.
Yeah, that would prove that they're not square. If the distances are not the same, it proves it's not a square because all the distances have to be the same. So we're going to do for BC, 3 minus 1 squared plus negative 1 minus 4 squared. Three minus 1 gives us 2 squared. Negative 1 minus 4 gives us negative 5 squared. So we get the square root of 4 plus 25. So is the distance the same on this one?
Yeah.
Yup. Keep trucking. I know. Because this is also just the distance. If all 4 distances are the same, all that proves is rhombus. An evil one. Sorry. I'm doing this in my college course as well, so torturing you because I get tortured as well. CD square root of, I can't see, negative 2, I don't know where I'm getting there, we go, negative 2 minus 3 squared plus negative 3 minus 1 squared. So we get the square root of negative 5 squared plus oh, I missed the negative sign there. Here we go. 3 plus 1. So it's plus negative 2 squared. Equals, once again, square root of 25 plus 4. So once again, we have the square root of 29. And we're almost done with distances. Yes, dear?
I swear, this
That's
is last.
negative 3 plus 1?
Yeah, negative 3 minus negative 1.
Okay.
Yeah, the double negatives. What's up?
If it's negative 3 minus negative 1, isn't that...
Negative 3, that becomes negative 3 plus 1. Yep. Yeah, the signs are killer. All right. The last distance. Distance of D to A. Square root.
Start with negative 1.
You can do negative 4 minus negative 2. You can absolutely do it that order. Negative 4 minus negative 2 squared plus, there we got it, 2 minus negative 3 squared. Square root. -4 minus -2. -2 squared. Plus 2 minus -3. 2 minus -3 squared. There we go. 4 plus 25. Once again, we have a distance of 29. So that, all that's proved is that the sides are the same length. So it's proved rhombus, not square. We got to see if our lines are parallel and they form right angles. Yes, dear. This proves that all the sides are congruent.
I have a question. Why is
Why is what like that?
nothing?
Okay. All right, this just proves the sides are congruent. It doesn't show us anything about the angles or the slope of the lines.
When are we going to use this in life?
You'll use this in calculus. That's why this is pre-calculus. Using calculus. Calculus, especially Calc 2, is all about shapes and volumes. So you take shapes and then you spin them to make volumes. Yeah, you use it in calculus. So real life, practically not. Calculus, yeah, lots. Lots and lots. All right. So also that's one of those things, once we get to the higher math, you have to stop asking that question. Once we get up to this level and higher, if you ask me when are we using it in real life, you in the wrong class. Just saying. Because real life, it becomes a stretch. A big stretch, unless we're doing, explorative mathematics or doing studies or maybe some high order engineering things. But we still got to find our slopes here so we can prove our square. So slope we call M. We're going to do the slope from point A to point B. How do we find slope again?
Mx equals b.
That's a line. We don't need the whole line. Yeah, the change in y over the change in x. Rise over run. Y's over x's. So we're just going to take the point values. For A and B, it's 4 minus 2 over 1 minus -4. It's that long. It's 4 fractions. So our slope is 2/5. Slope of BC. Y's over x's. Rise over run. -1 minus 4 over 3 minus 1. Our slope is -5 over +2. Just gonna say, on a square, do they all need to have the exact same slope?
So we're done.
Do they all have the same slope? No. Positive slope, negative slope.
Are you serious?
Positive slope, negative slope.
How many slopes?
So you get all of
CD. All right, find the slope of CD.
2/5.
Yep, because it's -3 minus -1. Watch our signs. -2 minus 3. So we have -3 minus -1 becomes -2 over -5. Also known as 2 over 5. So we have this one that matches this one. So we have a pair of parallel lines. We got one more line to go. Nice try, bucko. D to A.
Oh my god, that's crazy.
-3 minus 2. -2 minus -4. -5 over 2. So these two lines have the same slope. We've proved parallelogram. How do we know that those are right angles? Reciprocal. It's opposite reciprocal proves right angle. What is the opposite reciprocal of 2/5? -5 over 2. So 2/5 is opposite reciprocal. Don't question me on spelling. -5/2, which proves perpendicular. So these guys are parallel. These guys are parallel. And we have right angles. And we have all the sides different. Or all the sides same, sorry. Which means this is a square.
Oh my god.
Yes, dear.
For the distance number for D to A,
Uh-huh.
you did 2 minus -3. But then down there you did -3 minus.
I just went the other direction. I just put the D point in front of the A point. It doesn't matter which one's point 1, which one's point 2. Okay, so this is a square because all the sides are the same. We have two sets of parallel lines and the slopes are opposite reciprocal, meaning they are perpendicular. Okay, we have one more piece you're gonna need. Midpoint formula. We talked about midpoints. Y'all know how to do midpoints. You guys have done midpoints before. Find your distance and cut it in half. That's your midpoint. I will see. We'll probably tuck one in there, but it's one of those things we just kind of gotta fly.
Is this for today or for tomorrow?
Technically today, but we're really close to the end. We don't have time to do one with it. So write it down so you have it, because it may show up. But this is stuff that you've worked with before. How to find your midpoint, find your distance. Cut it in half. Halfway between the x values, add them together, cut it in half. Halfway between your y values, add them together, cut them in half. Gets you to halfway, because that's your midpoint. Okay? It's one of those things, it kind of flies. We're going to get into some real funky graphs this week. Just saying. Because we're going to be graphing some of these. You're going to be graphing circles and semicircles and circles. Yes. That's one of those times when I'm going, oh great, the college fair is in the middle of semicircle day. Yay. So excited that they've changed the schedule on me to make it during this period. That's super helpful. The college fair on Friday.
But it still means getting.
It's this period. Friday. It's the same one as yesterday. It's the 3-1 from that yellow paper.
Miss BSD,
What's up?
do you think you're able to print me this picture for Spanish?
I actually do not have access to a color printer.